Okay. Start with the following exercises where we are to rewrite those equations in logarithmic form. Now, I suppose that you have read the material, but perhaps you have reached part of uh, the part where logarithms are discussed, and maybe even the definition of a logarithm you haven't. But this concept is familiar to you from high school, and you may already know that logarithms are inverses of exponentials. So instead of getting, for example, the value of 2 raised to an exponent, what you do instead is find the exponent to which you should raise 2. So that we denote that by this notation, logarithm of 16 to base 2 equals 4. And again, this means the exponent to which I should raise the base 2 to get. So they are inverse process, logarithms and exponentials. So if I will ask you what is meant or what is the value of this one, logarithm of 125, you would think of an exponent, okay, to which 5 should be raised, the number there, input number 125. And we know that 5 cubed is 120. Okay, that is 3. Okay, and we can rewrite this into its exponential form this way. 5 cubed equals 125, but we can uh, see that by, or quickly rewrite that by making arrows like this, okay, where you start with the base 5 and then you raise it to the output 3 to get the input 120. Okay, so what we will do is rewrite those first 3 equations in their equivalent logarithmic form. So the first one tells us, okay, that you raise 0.5 to 4, you get 1 over 3. So here the base is 0.5, the input is 4, the output is 1 over 6. Now to write in logarithmic form, you use the same base. And instead of the output, you write the, or the input, you write the output. In other words, you just interchange the output and the input. Here the input is 4, the output is 1 over 16. So you interchange 1 over 16 is now the input and the output is 4. Okay. What did I raise 0.5 to get 4? That's 1 over, sorry. What should I raise 0.5 to get 1 over 4? Okay, one more time. All right, let me just ask some. Write number 2 in logarithm. Anyone? Can send it into the chat box. Can you give me the logarithmic form of that? 3 raised to 5 equals 243. The base, what? The base is, okay, that's correct. So the base is 3, and you interchange. Logarithm of 243 base 3 equals, it's the number to which I should raise e to get, and that. And How about number 3? I've discussed yesterday in the exercises the definition of E, how it was obtained, and it's just a constant like I, rational number. It's approximately 2.78. Can repeat that to get write it to 9 decimal places. Anyway, it's just a constant, just a real number, so it can be treated as any other base, okay, like 10, which is the common base, or any other base 2 or, and that is in exponential form. That is true. Any number raised to 0 equals 1. So we have, okay, in logarithmic form, the base is, we use E, and then we interchange, and we have this logarithmic equation equivalent to the exponential form here. We read it as logarithm of 1 to the base E equals 0. What should I raise E to get 1? Well, obviously, have to raise it to 0. Any number raised to 0 would yield. Now, there's a spatial notation when we use E as our base. It's actually called the natural base, the natural number. So that E to the x is the natural exponential function, while its inverse, logarithm base E, is called the natural logarithmic function, and its spatial notation is ln. Okay, so we can rewrite that as ln of 1 equals 0, so that there is no need to write a base there. It's understood to be the natural base. So you can read it as a natural logarithm in I think Latin, or I think it's Latin. It's the verb, it's the noun first before the adjective. Okay, unlike in English, it has to be the adjective or the noun. In Tagalog, either way, right? Like pulang kote, pula, but in English it has to be red car, not. But in Latin, it has to be the noun first. That's why ln, okay, for natural logarithm. I think it's logarithm. I forgot, naturalis is, hence naturalis Latin. Forgot for logarithm. But anyway, the function here, ln of x, logarithm of x to base e, is called the natural logarithm. And again, it is assumed that you do read. But anyway, I try to make the exercises understandable, even if you haven't read the. Okay, so let's continue. Now we will do the reverse. Given the logarithmic equation, a logarithmic equation, we write in exponential form. So we look at the first one there, number 4. We are told that logarithm of 25 square to base square root of 5 equals 4. And you can rewrite this in exponential form in 2 ways, or I mean, using 2 different approaches. One is by taking note that the base is square root of 5, and you just interchange square root of 5 raised to 4 equals 25. Change the 2. The input becomes the output. Okay, or you can draw arrows here in a counterclockwise fashion to rewrite that. Square root of 5 raised to 4 equals. Okay, now number 5 has base what? If the base is not written and you use the usual notation for logarithm, it's understood to be base 10. Yes, we call it a common base as opposed to the natural base E, 2.71. So we have the logarithmic equation here. Logarithm of 0.001 equals -3. okay, that could be obtained without being given the -3 there. What should I raise 10 to get 0.001? We know this moves 3 decimal places to the left, so it is negative. Okay, now we write that in exponential form. So you can make it this way: 10 to the -3 equals 0.001. I raised 10 to -3, 0.001. Now, rewrite number 6 now in exponential form. Quickly, give the answer. You can unmute your mic. Write it. Waiting. Rhythmic form. 3 halves to the -4. Okay. And equals 16 over 8. And of course, you can check that. How do you evaluate 3 halves to the -4? You interchange, right? You make the exponent positive, you take the reciprocal, and you apply the laws of exponents. 2 to the 4 is 16, 3 to the 4 is 81. Okay. Okay, evaluate without using a calculator. Number 7. That's base 10. What should I raise 10 to get 1,000? 3. Okay. Number 8. 0. Correct. What should I raise 13 to get 1? 0. In fact, logarithm of 1 to any base is always 0. Okay. What should I raise 8 to get 1? It's always 0. Or if we write in the equivalent exponential form, a to the 0 equals 1, and that is true. Okay, what is logarithm of okay, 243 base 3? Okay, fine, correct. At least now you understand what logarithms, okay, mean. So how about number 9? There's no exact whole number to which you could raise 4 to get 32, right? 4 to the 1 is 4, 4 squared is 16. Once you try another multiple or power, you get more than 32, as in between 2 and 3. In fact, it's 2.5. Okay, if you raise 4 to 2.5 or to 5 halves, that's equivalent to, you have an index, right? Square root of 4 and then a power of 5. That's 2 to the 5. That's 32. But you can get that. Of course, it's not always that easy, where it's just midway between two whole numbers or integers. You denote this by x instead. Without using a calculator, suppose you are to show this, then you have to do it this way. Denote that by x, and you solve for x. And instead of looking at this in logarithmically, you look at this exponentially. That is, you rewrite it in exponential form. So you do that thing again, 4 to the x equals 32. And this is easier to handle because we are used to computing exponentials other than logarithms. And I have discussed yesterday how to solve basic exponential equations where you can simply convert to the same base. Is 4 base 32, 2 is their common base, so express each. 2 squared, that's 4, and 32 is 2 to the 5, and you apply loss of exponents as discussed yesterday. Let me give that again. A to the m to the n equals a to the mn. In other words, if you have an exponent within an exponent, you just multiply the exponents. So 2 times x, or 2. And once you have the same base, you just equate the exponents to each other. 2x equals 5. So x equals 5 over, as tested out, 2.5. Okay. That's of course without a calculator, but since you are allowed, okay, to use a calculator, if exercises like these will ever be given, you will have to show your solution or solution. So next, evaluate without a calculator still. Number 10. Yes. Trial and error. You know that 49 and 7 are related? The square of 7 is 49. So somehow the answer has to be related to 2, or fraction of 2. Okay. Okay, -1. Correct. That's without having to show your solution, of course. You can try raising 1 over 49 to 1/2, right? The square root of 1 over 49 is 1 over 7. Okay. And you just take the reciprocal, so that's the negative, right? There's this law or definition of negative exponents. Right? A to the negative n equals 1 over a to the n. But to be more systematic, denote that again by x. You are required to show your solution. Then convert again to exponential form. 1 over 49 to the x equals 7. And then convert to the same base. 49 is 7 to the -2. And then you multiply the exponents again. 7 to the -2x equals 7. You compare the exponents, because you already have the same base there. -2x equals 1. So x equals -1/2. Not done yet. Number 11. Ln is base e, okay? -4, correct. Why did you answer -4? Can you explain, Usologo?
Because the natural logarithm and e cancel out.
They are inverses of each other. So you can think of it this way. This is logarithm base e. What should I raise e to get e to the -4? Obviously. In general, ln e to the x, please take note of this. It's an identity that is very important, especially when solving logarithmic exponential equations that involve the use of the natural logarithm and the other equivalent identity, which has the exponent, natural exponential first. E to the ln x is also. This one means you're raising the base e to the natural logarithm of x. Maybe confusing to you, but okay. It's like, okay, if you define it, okay, this one here means the base or the exponent to which I should raise e to get x, right? So if I raise e to that, I get x. Well, that might be confusing, but you can just look at this as inverse functions. This is base e exponential, but the exponent is logarithmic or logarithmic base e. So they undo each other, so you get back to the input number x. Like squaring and square rooting. You square the number, then you take the square root of the result, you go back the input number. So for instance, e to the ln 2 is, without a calculator, 2. E and ln cancel out. And more generally, we have the following. Logarithm to base a of a to the x is x. Okay? Oops. They are inverse functions. This is logarithm base a. This is exponential base a. So we get back to the input x. And the other way around, a to the logarithm of x base a is still x. Okay, this is a base a exponential, but the exponent is a logarithm to the same base a. They cancel each other out, get back x. In fact, if you've read that section on inverses, you know that inverses undo each other. More generally, means that if f and g are inverses, they are inverse functions, then f of g of x is x. You apply one to the other, you get back to x. Similarly, g of f of x equals x. You always get back to x, the input. And that applies to logarithms and exponential function. Logarithmic. Okay, so this one means this is equal to -4. And how about number 12 here? What is e to the ln 5? I have just discussed that. What is e to the ln 5? 5. ELN. Okay, simplify that one. So notice you have a logarithm base 7 and you have an exponential base 7 inside, which can be simplified. Try to simplify the inside first. Use this law, a to the m over a to the n equals a to the m minus. How will the inside look like now? It is 7 raised to? Anyone? Yes, 7 raised to 40. The answer. Logarithm base 7 of that is 14, yes. So simplify the expression inside. You subtract the exponents. So that becomes 7 to the 14. 7 plus 7. 7x cancelled. And then use that property. The fact that they are inverses tells us that the answer is. Any questions so far? Oh, let's look at this. Okay, a minute. Okay, answer. You have to begin inside, innermost, outermost. So let's simplify this one first. What is that? The one I answer. It's just 3 halves squared cube. We apply a law, a to the m to the n equals a to the mn. So you multiply, right? 2 times 3. So that's just 3 halves to the 6. Yes. So let me rewrite that now. Logarithm to base 2 over 3 of 3 halves to the 6. Okay, we're looking at this now. Okay. We cube pa sa labas, later na yan. Let's simplify that one, which is this one. We apply the identities. Look at the bases. Oh, okay, no need for, we have to take, yes, -6. Take the reciprocal. They are reciprocals, right? So it's -6. Or if you cannot see that, you can cut it this way. You can write 3 over 2 as 2 over 3, but you make the exponent. Now you have the same. Okay? And they undo each other. So -6. Then finally, -6 itong nasa loob. -6 yun. Tama ba? -216 to? 6 times 6, 36. Tama na. Okay. I'm doing these exercises to deepen your understanding of logarithms, meaning of logarithms, and some basic proper. Okay. Tignan natin to. Anyone? The outside first. Madaling i-evaluate yung nasa taas. What is the value of that? Okay, good. What should you raise 5 to get 125? Obviously. So we'll change that. 3 na siya. Next, the inside. What? I raise 125 to get 5. Madali na yan eh. Kanina 3, this one. What should I raise 125 to get 5? 1/3. Cube root lang kasi yan eh. At ano ang cube root ng 125 at 5? 5 times 5 times 5 is 1. So 1/3 cube. Okay? Now don't get scared. Just begin from inside. Okay? Out. Innermost to outermost. Begin there. Move outwards. Then evaluate base 4. Kung munang tignan nyo. Okay, 2 minutes. Okay, correct, 1/2. So ito muna, no? 8 to the negative 4 over 3. This is the index, so that's cube root of 8. This is cube root of 8 is 2, so 2 to the negative 4. We won't evaluate that. So 2 to the negative 4. Then you take the square root. Okay, 2 to the negative 4 yung nasa loob. Square root of that. That's raised to 1/2. And then you multiply. That's negative 2. Then we move out. Times 32. 32 is 2 to the 5. So add, remember, a to the m times a to the n equals a to the m plus n. So you add 5 plus negative 2 is this one here. And then take the cube root of that. Obviously, that's 2. Cube root of 8 is 2. So you have 16 times 2. That's 32. And then you take the fifth root and 2. So in other words, after a long computation, the inside, the input is just. And what should I raise 4 to get 2? That's 1. Square root of 4 is 2. Any question on this? Okay, next. Okay, last one for today. Okay, try this out first. Okay, hint, you need to use one of the identity. Either this one, okay, the fact that logarithms and exponentials undo each other, or this one. And you know that it's the second one, right? Because of the form. So how will you use this to evaluate that? Now, if this were 2, let me erase. If it were this, it would have been easy, right? What is this? 2 raised to logarithm base 2 of 15. 15. Okay? Mag-cancel ito. Base 2 exponential, base 2 logarithm. 15 yan. But, notice, kaiba yung base. Base 2 yung exponential, base 4 yung logarithmic. But there's a trick here in this question. You can make them both in base 4. Naka-base 4 na to. So yung isa, kailangan ma-base 4. That's the thing you have to do. Okay, that's the idea. Yes, Mr. Guevara. So proceed. Okay, that's correct. But why is that so? You square. Why can you square 2 when you're raising it to the whole? Because of, remember the property that a to the m to the n equals a to the mn, and vice versa. A to the mn equals a to the m to the n. So that means you can write this one, this is the trick, as 2 squared raised to that number, right? If you multiply, this is an exponent within an exponent. So if you multiply, get back to this, which makes it, okay, 4. Okay, this one I mean. And thus, we now have the same base for both the exponential and the logarithmic. And they undo each other. So the answer is 15. Now, this is a good question which tests you on your understanding of logarithms and the properties as well. So this is like a synthesis of several properties of or identities and properties of exponent and logarithms. Dito ginamit natin properties of exponents, and then here we use rather the fact that logarithms and inverses are sorry, exponentials and logarithms are okay. So no classes next week. but I encourage you to still do exercises, at least perhaps 5 a day. That will uh, help you to lighten up the load of having to study or prepare or practice, doing them all one day, right? Days. If you do 5 a day, then in a week you will be able to do 35 exercises in no time. And then what else? Your midterm results. Give me 3 weeks to check, right? And quiz number 3 will be about module 4. No quiz for module 5, which is trigonometry. Prepare for the next quiz because usually it's the hardest of all the quiz because Excolog is really a hard topic for student. Uh, a Waterloo, okay, of math is already a Waterloo for many, but among the topics here in your math subject, it's the topic on Excolog that the Waterloo. So that those who get high in the first two quizzes usually, or not usually, sometimes get low in the third. But to avoid that, you just do all the exercises I have given in the module. Like actually, these ones were taken from the exercises given there. Okay, practice sabi nga, di ba? Makes perfect, right? And then tomorrow I will hold classes still in my other 2 sections, and I will be discussing the exercises after. You want to attend, in case 1 o'clock to 3 o'clock, you want to, you're not required, of course. But if you're free and you just want to uh, study, synchronously instead of having to view it after class. So the questions regarding the midterms or things discussed today. Okay, so I'll be ending the meeting for all.